I'm Erin B. Marion, and welcome to STEM to Share. In today's episode, I'm interviewing
Meghan Saltzer. I am a manager in the Safety, Health, and Security Department at HHMI's Genelia Research Campus in Ashburn, Virginia.
Can you tell me what the Howard Hughes Medical Institute is?
HHMI is an organization that was founded on the principle of funding people, not projects. So HHMI primarily is a funder of research. They fund individuals based on kind of their experience and their ideas rather than on a project basis, which is what most funding institutions do. So the NIH, or some of the government funders, you have to propose a specific project. But HHMI really invests in people and what people, ideas they have, and gives them freedom to pursue kind of riskier scientific endeavors. HHMI also has a science education program. They have a group called Biointeractive that does a lot of scientific education. They also have a division that makes scientific productions and films, which have received a lot of acclaim. In addition to that, we do fund people all over the United States that are at many different institutions, but Genelia, where I work, is its own research site. So it's the only standalone research facility that HHMI has. And our work primarily focuses on studying how the brain works and how it enables you to think, feel, process information. And we also have a group that does a lot of computational science related to the neurological work that we do, but also just in general ways you can use computation to address scientific problems. And we have a group of kind of tool builders. There are probably too young to know a lot about MacGyver, but they're kind of our MacGyvers. They develop new tools, sensors, dyes, things that scientists can use to push the limits of science and answer some really cool scientific problems. So that's a general overview of HHMI and Genelia.
Can you tell me about your job as the manager of safety, health, and security at your research campus?
My job and the job of my team, we have a couple different things. So if we go through the department names, so we have safety, health, and security. So safety is related to all aspects of safety in the workplace. And I know that a lot of people tend to think of safety as, you're the person that goes around policing with the orange vest and the clipboard and you tell people what they're doing wrong. But it's actually a lot more than that. We do some of that to some degree, but the majority of what we do is helping scientists do good risk assessments for what they're working on. So really looking at what are scientists doing, what are the risks to themselves and the risks to the environment, and what are ways we can mitigate those risks. It's kind of a really cool problem. It's a puzzle. It requires a lot of scientific knowledge. My background is actually as a molecular biologist and a cancer biologist. So really understanding the science of what people are trying to do helps me understand what they want to do, and then I can figure out where the risks are and kind of workable solutions so that they can protect themselves. In addition to that, we do a lot of compliance stuff, which is maybe the boring aspect of it, but it's fun to figure out ways to make sure that we're in compliance with regulations while not putting up a lot of barriers to the science. So not putting up roadblocks, not kind of interfering with their ability to do their job at the pace they want to do their job. So trying to figure out workable solutions. So it's a lot of problem solving, which is a lot of fun. And it's not the same problem every day. It's very different. And, I can never predict what I'm going to do because we don't know where the science is going to go or what people are going to want to work on and what problems we're going to have to address related to those things. We also have a little bit of a wellness program that we started about a year ago. Part of that is recognizing that a lot of people in postgraduate studies and certain postgraduate careers have higher rates of mental illness and mental health issues, and the sciences is no exception to that. So we're developing a wellness program to help support the mental health of our researchers so that they can continue to do what they're doing in a healthy way for the long term. And then we also run the security department. So we do campus security. So access to the building, monitoring campus security. How do we make sure that people that aren't supposed to be there don't get on campus? So it's a pretty wide variety of things that our department does. But it's really cool. I mean, as a career, it's not something, I never set out to be a safety person. That wasn't, when I was sitting in your shoes as a high schooler, I was going to be a cancer researcher. I was going to cure cancer. And, through my career, it's really been an evolution and exploration of different things to do with my science background. And I fell into safety because it seemed fascinating when you view it as a problem to solve and a challenge to try and figure out how to do it in a way that keeps everyone safe, but still allows research to move forward.
Can you tell my audience what it means by biosafety and biosecurity?
There are many different definitions of biosecurity. So I will admit that my definition is going to be a little bit biased, but I'll try to highlight some of the nuances. So biosecurity is really thinking about stopping diseases from spreading. It could be unintentionally. People in agriculture refer to biosecurity as, keeping herds safe from illnesses, keeping diseases from spreading on farms or in crops. There's also the facet of biosecurity where you're trying to make sure that people with nefarious purposes, so people that may want to do harm, can't come in and steal materials from a laboratory that are hazardous. So you don't want a terrorist, for example, to infiltrate your lab and steal your anthrax stocks and then make a weapon out of it. So, but biosecurity, like I said, it's incredibly nuanced. There are a lot of different areas and facets of it. Most people in my profession deal with biosecurity primarily within the realm of using what are referred to as select agents. So these are a group of agents that the US government has said require additional security measures if you're going to work with them. And they use biosecurity to make sure that we're letting people work with these agents in a way that ensures we're not, exposing the world to people trying to get into the labs and breaking it out. So it's a lot of physical barriers, information security, practices, procedures, training. So it's a very broad field, and of the biosafety, biosecurity is a little bit of a newer field that has kind of evolved. And I would encourage anybody, if you're interested in learning more about biosecurity, to check out APSA International's website, the American Biological Safety Association. The website's apsa.org. There's lots of information on biosecurity, and as an organization, we're actively working on developing a credential for professionals who are involved in biosecurity. On the biosafety side of it, it's making sure that whatever you're working with stays in the lab. You don't want to take it home with you. You don't want to release it out into the environment. So it's all about containing it in a space and working with it in a way that allows you to solve your scientific problem without exposing people to that risk. So if you, at a very basic level, biosecurity is the intentional release of something. Biosafety is that unintended accident, unintended consequence of working with the material. So they really are synergistic, and a lot of the same things that you would do to maintain both biosafety, you also do to maintain biosecurity. But it's an awesome field. And again, I would recommend anybody that's interested to check out APSA International's website, which is just apsa.org.
Can you tell us about your PhD in cellular molecular medicine and how it's different from a regular medical degree?
So I got my PhD at Johns Hopkins School of Medicine. So I did my PhD at a medical school. And the program that I was in is cellular molecular medicine. And it was kind of a large umbrella program where you could study any problem related to many different branches of medicine: immunology, cancer biology, infectious disease. So it was very, very broad. So a lot of my training and my classes were these very broad subject areas. And because it was an umbrella program, I had the opportunity to do my PhD research in labs, from infectious disease to immunology to cancer biology to neuroscience to neurology. So it was great because it gave you a real background of all of these different fields. And, you know, when you're looking at, you know, how the immune system works, you can't necessarily uncouple that from how all the other body systems work. So it gives you it gave you a good overview of everything that was going on. How it's different from going to medical school, well, I didn't interact with patients. You learn all of those things when you go to medical school. You learn how the immune system works. You know and learn about infectious diseases. You learn how all the different body systems work. But I was not focused on, you know, patient care and, you know, interacting with patients and working with them to solve their own personal health issues or to remedy those. Mine was much more research focused on, you know, providing that more basic science foundation that would eventually evolve into something within the clinic that doctors can use to help patients. So my PhD research was around glioblastoma, which is a really horrible brain tumor. And we were working on trying to figure out how that cancer worked, what happened, what was different about those cells, how did it start, was it a mutation, was it an environmental concern, and what are potential ways you could treat it to kill the tumor, slow its growth, with the intent that those would eventually develop into therapies that an oncologist could use to treat those types of tumors. So it was a lot more about that basic research that would potentially evolve into the clinic versus focusing on patient care. That said, I worked with a lot of doctors because if you don't understand what's going on in the clinic, if you don't understand what they're seeing and what the disease is and what's happening, then you don't have a lot of information to base your science on. So the information from the clinic is really important to see what was going on. So probably just as an interesting thing, I wasn't involved in patient care, but I had a lot of really great mentors that wanted me to be aware of what was going on in the clinic. So I had a few mentors that would take me, since it was a teaching hospital, would take me into appointments with patients that had the diseases that I was studying. So I got to hear from the patients what their experience was and what it was like for them to have these diseases and why it was important to them to have a cure. Probably one of the coolest things, I actually got to go watch a brain surgery once. It was really cool because I actually got to see them working on somebody's brain in person. And it was just, was one of those experiences that I never would have guessed I would have been in an operating room at one point in my life. And it was really cool to kind of see what they were doing and how they were trying to help that patient.
What do you find exciting about your job?
I think my two favorite parts about my job, one is related to the subject matter, and that's that it is interesting. No 2 days have been the same for me since I started at Genelia. So I've been there for about 6.5 years now, and there's always a new problem. There's always a new technology that we don't understand how to control or what the risks are. You know, if you had talked to me back in December, I would not have said that I'd be involved in trying to help spread or trying to help minimize the spread of a pandemic within my workforce. You know, that's something that I never thought I'd be doing. But it's cool because you're not working on the same thing day in and day out, and you have to keep learning. You have to keep growing. You know, school doesn't end for you when you're out of high school or you're out of undergrad or you're out of graduate school. You really need to keep learning and keep evolving. And so I get to learn something new every day, which is really, really cool. The other part that's less related to the subject matter, but I think is really important as you're picking a career or picking a place to work, I get to work with some really cool people. We have a lot of really, really smart people, not only in our laboratories, but throughout the entire organization. And I get to learn from them all the time. And they come from very different backgrounds, very different perspectives, have a lot of different knowledge. And it's really helped me learn how to look at problems from many different angles and get a lot of different perspectives. So I think that, you know, as you're choosing a career and you're thinking about where you want to work, what you're doing is important, but who you're doing it with is also incredibly important. And the who you're doing it with oftentimes makes the job very, very special. or very, very awful, depending on who your coworkers are.
What advice would you give to students looking to enter a job like yours?
I think in general, for any science career, be open, have a plan, but be open. Especially at the high school level and even in college and grad school, there is a whole world out there that you may not have been exposed to, right? There's lots of different things you can do with a science background. It's not just becoming an engineer, and there's nothing wrong with any of these careers, but it's more than just becoming an engineer, or more than just becoming a bench scientist, or more than just becoming a doctor. There's a lot of opportunities out there for people with this type of background to help people that are in those fields do their job effectively. So I'd say have a plan, know where you want to go, but be open to the experiences that you're going to have. Had you told me that I would be in a safety field 15 years ago, I would have laughed at you. I'd be like, no, I'm going to cure cancer. That's what I'm going to do. That's what I want to do. I'm going to go to grad school. Why would I waste my time learning anything else? And, as I went through the field, it was, you see things and you're like, oh, okay, well, maybe, yeah, somebody needs to research brain cancer, but that's one problem. I'm going to focus on it for the rest of my life. I don't think I can do that, right? Like I want more variety in my life, but what does that mean? And, I ended up in a fellowship or an internship at AAAS. And through that, I found out about the fellowship program that I went to, which is the National Biosafety and Biocontainment Training Program. And, my mentor in the internship said, well, I'll introduce you to the fellowship director. So I went and I spoke to the fellowship director, and he completely changed my view on what safety was. Because in my mind, it was the annoying person that came into my lab and told me I couldn't eat at my desk. But that's not what safety was. So through having that conversation with him and learning about what it actually was, I was like, wow, that's really cool. I want to try it. And because I was open to that single conversation, it kind of changed the trajectory of my career and where I went.
Can you tell my audience what a biosafety level 4 lab is?
So BSL stands for biosafety level. So in the United States, there are 4 biosafety levels, 1, 2, 3, and 4. And this is a category of rooms or buildings that are designed to handle different types of pathogens, so different viruses, different bacteria, different fungi. BSL-1 is for the stuff that most people can be exposed to and it won't make them sick. BSL-2 is probably the most common umbrella, and those are going to be things that are a little more dangerous. BSL-3, BSL-4 are reserved for the most dangerous pathogens. So for example, BSL-4 would be things like Ebola, Lassa fever, Marburg, and it's a highly engineered, highly designed environment where there are a lot of, the airflow is highly managed, the waste is highly managed, everything is managed down to the smallest detail, because obviously we wouldn't want Ebola to be released out into the general community. There are not many BSL-4 labs within the US. There are about 10 to 12. If people are interested in more learning about them, the NIH's Integrated Research Facility has a lot of really good information online about what a BSL-4 is, how it's made, and how their facility is set up.
Any additional information or advice you'd like to add?
I would just like to say that one of the things that has been incredibly helpful for me in my career is talking to a bunch of different people who do very different types of jobs. So if I could give people thinking about STEM careers a piece of advice, is don't be afraid to reach out and ask people to talk. You don't have to have an ulterior motive. Most people are going to be incredibly willing to share their stories, to talk about why they made decisions, where they went, what they do differently, what's out there, and bring you into their network. So my mom, from a very young age, always told me, what's the worst they can say if you ask? The worst they can say is no, or not respond. But I think that if you start reaching out to people and you start having these conversations, more often than not, you're going to find somebody that's willing to share their experience because they've had people that have done it for them and they want to pay it forward. So never be afraid to ask for information, for help, for advice. There's lots of it out there. So that's the first thing. And then I've already said it, but I wanted to say it again, is to be open to the experiences life has for you. Don't be so married to your concept of what it is to be a professional or what you have to do with a degree or what someone's going to tell you that you have to do. Find your place, find your niche where you're happy, where you love your job, and you get to do what you love every day. Being an adult and being a professional does not have to be a boring slog where you go in every day and you're just grinding it out to grind it out. It's meant to be fun, and it's meant to be more than a paycheck. So find your passion, and keep asking yourself what your passion is so that you don't get bored.
Thank you all for watching. Please like, share, and subscribe, and follow me on social media. Links are in the description below. Bye!